Good afternoon all. Time to get the PWM5 Femto outside and doing some work, actually charging a battery. I'm going to move this closer and closer to the camera lens. But before I do take it outside, I need to conformally coat it with a conformal coating, which will seal all the components away from the nasty British weather. But before I can do that, I need to solder in the final component, which you can see there is hanging through the holes, and that is the transient suppression diode. So let's take a look at that component. So here are the transient suppression diodes. They're called transorbs or transils, or they've got various different names. This one is the P6KE 33CA. So I'm just printing out the datasheet. Let's have a look at that. So here's the little fuse datasheet for the P6KE series. Now, it's a series of devices with different suffixes. The first one is a number, so let me just scroll down to those. And there's a whole range of different voltage numbers. Now, I've gone for the P6K33CA. The CA is the bidirectional part, and the A is the unidirectional part. Let me go right back up to there. You can see the unidirectional part is marked like a diode. It has a cathode indicator there. The bidirectional part, the CA, actually has no marking at all because it doesn't have a cathode. It actually has two anodes. You can see that down here. This is the bidirectional, the CA. This is the one I'm using. It looks like two Zenas pointing at each other. It's probably not two physically separate components in there. It's probably one device, but it has a breakdown voltage which works in either direction. So this diode doesn't conduct at all until, in the case of my part, you hit 33 volts. And now it's not a sharp cutoff at that voltage. There is a tolerance on that, and it will start to conduct a little bit below that. But at that voltage, you hit the breakdown voltage. It doesn't actually in the datasheet talk about the Zener voltage, but it will start to conduct at that, and it clamps any high voltage transients. And in fact, if we go back to the top, it says the P6KE series is designed specifically to protect sensitive electronic equipment from voltage transients induced by lightning and other transient voltage events. Now, it's not going to hold off a direct hit, even though it is capable of taking 600 watts peak pulse. But if there was a lightning strike nearby and it induced something into your long wires running to your solar panel, then this device could, up to that power rating, clamp it and stop it damaging other components in your circuit. Now, originally, when I first bought this diode, I was using the 30CA, but I didn't like this number here, this 25.6 volts reverse standoff voltage. To my mind, what that said is that it would start to conduct at 25.6 volts. And I was a bit concerned that that's quite close to the open circuit voltage of a 36 cell solar panel, which is about 22 volts. So I upped it slightly to the 33CA. I mean, I could probably up it quite a lot. Remember, this is supposed to take out spikes. I put it up to the 33CA. That's got the reverse standoff voltage of 28.2 volts. An actual breakdown voltage of somewhere between 31.4 and 34.7. But I felt that that 28.2 was sufficiently far above the sort of 22, possibly 23, 24 even, open circuit voltage of a solar panel that that wasn't going to cause any significant leakage through that device. So yeah, these don't have a band, so you can put them either way around. It really doesn't matter. And funnily enough, the silkscreen on the board, oh, I might show that, actually does have a band. So I don't know why the component in the library of EasyEDA actually has a band for what is a non-polarized device, but no, those have no band at all. They go either way around. Okay, warming the soldering iron up. Oh, no, I'm not. I am now. And let's get this thing soldered in. Yeah, it's a little bit difficult to see now, but you can see that there's some sort of cathode marking on this device, even though I picked the 33CA. So it's not strictly right. I mean, I probably could have gone in and edited that and pulled it out, but, well, I didn't think it was that important. Anyway, let's get the components soldered in. Now it does sit slightly high off the board because the little link wire to which the two black wires are connected is underneath it, but actually it's not even as tall as the MOSFET, so I think that's absolutely fine. Now let's solder it in. Okay, here we go. Get some solder on there. It's going to take a while to warm that leg up. That's gone on nicely. I'm going to have to flip this round now. I don't like the way that the crocodile clip is going to put a little indentation in the wire, but anyway, I'll have to live with it because there's no blue tack for solution for this that I could think of. So let's get that one heated up, soldered in. There we are. Yes, I mean, I don't know how effective this thing is, whether it would actually work if there was lightning nearby, but I kind of like the idea of having it. There's no real way to test it, well, not easily. I mean, I can't summon up lightning. It would be quite a complex test rig involving big Tesla coils, probably. Probably quite fun, but difficult to do. Right, now we come to the bit that I was looking forward to, the conformal coating. Right, so here we go with the UV glue. Now I think I managed to get this one, the leaky one, flowing again. So let's see whether that is indeed the case. Oh yeah, there we go. I'm not quite sure what the viscosity of this stuff is. It's not flowing very well. This could take a while, but it does seem to be flowing down into all the little gaps. But I have to coat the entire rear surface of this board with this UV glue. I hope there's enough in here. Just want it to come out a bit faster, really. I think I've done everything. I think all the components are on there, because this is a one-way trip, really. There's no going back from this. Yeah, it's quite difficult to see what I've coated and what I haven't. One thing it's not doing is it's not running over the edge of the PCB, so it does seem to have about the right viscosity. That looks pretty good. I think I'll just load a little bit more on, but I don't go mad, because if it bulges over the sides and runs off the edge, that won't be good. But let's just put a little bit more on there. Right, I think that's enough, so let's get some UV on this now. Ooh, that's interesting. There's a wisp of smoke or something coming off it. Does it get hot when you activate it with UV? I'm not quite sure how much UV to give it, because it's very thick. There's 2 or 3 millimeters there. And someone was saying in the comments the other day that it might just trigger the top layer and what's underneath will stay liquid. But I think because this is going to live outdoors for the next few weeks and months, I mean, the UV in the sun should finish the job. So even if I only get the outer coating of this done, I shouldn't really look at this UV light too much. I'm just trying to see whether it's run over the edge. I think it might have run over the edge just a little bit on this end, but it's run onto the back of the MOSFET tab, so it's probably not a major issue. And then if that feels hard, I'll just dab it with a cocktail stick. Then I'll flip it over and start doing the other side. Anyway, that's probably enough. Right, let's just check the surface of that. And that does feel like the surface, at least, is hard. So yeah, that feels good. I think that's certainly going to be solid enough to flip the thing over and do the reverse side. Good. Right, on the basis, some glue ran through to this side, and I think that might still be sticky there because it didn't get any... Oh, no, that's fairly hard. Didn't get much UV. I don't think I need this coaster now because it doesn't seem to be dripping, and I'm trying to protect my mat, but probably won't get any brownie points for using coasters to protect my mat, will I? No, right, let's start squirting glue on this side. I mean, it might use a whole tube of glue on this, or certainly half a tube, but these are 99 cents each. So, and I think you can get bottles of this stuff So that would be a cheaper way to buy it. So let's just continue with that, cover that microcontroller completely. I'll finish that off. I don't think I need to worry too much about fully coating the tab of the MOSFET, because I believe that tab's copper, and so that's not going to rust. I mean, it might oxidize a bit, but anyway, up here we were not really interested in that being in good nick. Also, the thing is, I'll probably put this in the heat shrink and put glue slugs in the ends anyway, but initially I won't. I want to put this out in the garden just with the conformal coating on. I haven't covered the top surface of the MOSFET either. There's no need, as long as I've covered the where the legs are, and I certainly have. There's a nice meniscus on that, a nice sort of dome. So let's get that UV... Oh, I need to clamp this because I don't really want my hand there when I start UVing it. So just looking through my camera screen, yeah, more wisps of smoke coming off when you put the UV on it. That's really interesting. It must get really warm, I guess. It's supposed to only take 5 or 10 seconds, this. Oh, it's probably not a good idea having that there in the UV light, is it, really? Otherwise that's not going to work again. Perhaps that's what I did wrong last time. Yeah, so as I say, I just want to coat, I just want to get the top surface hard, because this thing's sitting out in the sunlight, if there is ever any sunlight. There has been for a couple of months, but it's not so good now. It should all go off hard over the course of time, would be my guess. Right, that's probably enough. Let's try that. And yeah, that all feels hard. Not sticky at all. Absolutely good. Now, I haven't coated the edges of the PCB. I don't know how well or not well moisture will leach through the fiberglass. I mean, it should be resin impregnated anyway, so I wouldn't have thought moisture will get into the vias. But time will tell. This is my first of 10. If this fails after a period of time, well, I will have learned something, won't I? But yeah, that all seems hard. So I'm going to get some banana plugs in on this and take it outside. Right, I think I can see a little hole just down underneath the black and red wires, possibly running down inside the unit. So I'm just going to put a little bit more in there because it may not be completely sealed. Yes, it's much more difficult doing this with the wires on, but then you can't really do it before they're on, can you? Ah, now while I was doing that, a whole load of glue ran out the other side. So maybe it's all still liquid inside, or maybe that was the glue I was pouring in. Maybe that's a good thing, actually, that it's come out the other side. That probably might have sealed it. Anyway, let's get the UV on that. And I think I've managed to get glue over the tops of the MOSFET pins. They do run up quite high. And just about over the tops of the legs of the diode there, the transient suppression diode. All the other components do seem to be well coated. I've just broken some glue out between these two wires. I'm not sure whether that will have put a breach in there. But even if moisture gets down there a little way, really the main issue is when it gets down onto the components and starts rusting away or corroding the legs of the components and any tracks it gets to. But anyway, time will tell. Let's take it outside. Right, big battery. Charge controller with its conformal coating. Now I've plugged the solar connectors in first because there's no diode in this yellow wire. So if I connect red and black to the battery and then these two connectors touch together, the full current of the battery goes through the MOSFET body diode and boom! Which is why I always like to have the diode in this wire, but I haven't got it at the moment, so I'll put those in first. Then I connect these. Now I've got the usual problem here. These have all corroded and gone rusty and I'm getting really bad connections. Oh, I didn't show you the solar panel, did I? It's this big 80-watt one. Very nice. So I'm going to put the file to these. I need to make some 2018 vintage connectors, which are nice and shiny. These have all long since gone rusty, but let's just give them a quick clean up, see if we can get this thing working. So with some filing and some wiggling of connectors, I've got 1, 2, about 12.6 or 7. The solar panel, oh, I could tip that up a bit further. It's not it's not a very good day for it. Let's have a look. No, it's completely overcast, but that's a big panel, so it should lift the voltage of this battery. Right, the controller's saying 13.1, and the meter that I just put on the top of the battery is saying 12.9. Yes, there was about a 0.2 volt discrepancy, so I'll just sit here now for a bit because it's not too cold out here, and watch that go up, if that is indeed what it's going to do. Oh well, here's the conformal coating's first test, because it started to rain. So we'll see whether this thing can survive out here for the next few days. What's this saying? 1, 2, 3, 2, 13.2. It's going up. Right, this is a better meter because it's got 3 decimal places. So we can actually see movement. Movement appears to be down at the moment. That's probably more to do with cloud than the battery charging. Yeah, okay. I really want this to modulate. It's not modulating yet, is it? Nope. Still counting. Oh, that looked like about 13.4, was it? 3 or 4? I'll do 3. Oh no, probably 13.3. Well, that correlates with that. Come on, let's get modulating. Ah, look over there. Tiny bit of blue sky. I wonder if it'll come this way. Yeah, I really rather squandered this summer, didn't I? We had 2 months of pretty much clear blue skies. We had the best summer we've had for a long time, since 1976, I think. And my charge controllers weren't ready, and now they are. We've got this. Oh, it's the story of my life. So, can you see the LED from here? I don't think so. Let's see how close I need to get before we can see that LED flashing. Goodness me, that Femto really is quite small, isn't it? 1, 2, 3. Ooh. 13.36. And that's possibly even going upwards. Ooh, what do we have here heading in from the west? That could work. Ah, I do believe that's modulating. Now the camera doesn't show it very well because I think it's quite a fast pulsation. I think it's about 25 Hertz or something like that. And the brightness of that flicker tells you approximately where the pulse width modulation percentage is. That's quite flickery to my eye, so it's high. So it's just come off 100% and it's probably down at 90-80%, something like that. It will fall as the battery absorbs more energy. Oh, that's interesting. I just saw it say 13.500. It's pretty close, isn't it? Pretty close to 13.5. I've no idea which of these meters is accurate though. Well, look at this. The gods are on my side. All of them. Fred, Ginger, Tommy. Fantastic. It's getting lighter and lighter. I think we'll actually have some sunshine in a minute. Oh my word, the sun's out. So I just went and got this light bulb, 21 watt brake light bulb, and I've strapped it across the battery, and I was just wondering whether this will continue modulating. Let's have a look. Yeah, that's modulating. And whether it can keep a sustained 13.5. Yeah, that's not dropping down. So yes, we're now getting enough power through the charge controller that it's keeping the battery's voltage up while running that light bulb at the same time. So 20 watts, what's that, about 2 amps. There's 2 amps going through this. It's not warm, of course, because that MOSFET doesn't get warm. If I had a diode in here, the diode would be getting warm, because of course the volt drop across a Schottky diode is significant, 0.3, 0.4 volts, something like that. But the volt drop across that MOSFET is next to nothing. Yeah, that's all working rather well. The sun briefly came out. Well, the sun's properly out now. Properly out. I just wanted to show you the modulating on here. It's much less flickery. The LED is almost solidly on now, and that means that the PWM percentage is very low. Now that seems like the wrong way round, but of course from an energy consumption perspective, you want the LED to be virtually permanently on only when there's a huge surplus of power, or yes, power, and it gets much more flickery, so it's on less when there's not much, when it's still modulating, but there's not much of a surplus of power. In other words, when the PWM percentage is much higher. But yeah, I would say that's probably down to 1 or 2% now, because I've taken the load off the battery, I've taken that light bulb away, and so it's really not requiring much current at all to keep it up to 13.5 volts. So a very unflickery LED on the Femto. And there I shall leave it, and I'll leave it out here for weeks, and keep periodically checking on it to see whether it's still working. Oh my goodness, I've got a shadow. That's extraordinary. Good, so the PWM5 is back in the garden. Cheerio.